Good morning, kiddos. Today we are going to be talking about 2.1b, converses and biconditional statements. Yesterday we talked about the if something, then something. And these conditional statements were if your hypothesis, then your conclusion. The first thing we're going to talk about today is called the converse. And the converse is when you switch the hypothesis and conclusion. So it would turn into if la la la, which is your conclusion, then blah blah blah, and this piece is your hypothesis. So we switched the conditional statement from if hypothesis then conclusion to if conclusion then hypothesis. So let's do an example of that. I wrote up a conditional statement that says, if it is dark, then it is night. So since this is a regular conditional statement, this first piece after the if would be our hypothesis, and the second piece after the then would be our conclusion. Okay? And we want to write the converse, which means we have to switch the conclusion and the hypothesis. So this statement turns into, if it is night, then it is dark. The next definition that we're going to look at is called the biconditional statement. And a biconditional statement is when a conditional statement, so the original, and its converse are both true. We can also call this an if and only if statement. Okay? An if and only if statement. So let's do an example of this. Our original or conditional statement is going to say, if it is night, then it is dark. Okay? So this is our original statement. If it is night, then it is dark. And that is true. If it is nighttime, then it is dark. So I'm going to put a T right next to that. Next, we are going to underline our hypothesis and our conclusion. So since this is a regular conditional statement, after the if will be our hypothesis, and after the then will be our conclusion. Okay? Next, we want to write our converse, which means we have to switch the hypothesis and the conclusion. So this will turn into, if it is dark, then it is night. Okay? And this is also true. If it is dark outside, then it's probably nighttime. And finally, since both the original, the conditional statement, and the converse statement are both true, we can write our biconditional statement by writing, it is dark if and only if it is night. Okay? So you see how we drop the if and then to replace it with this statement, that if and only if statement. Okay, so let's do an example. Here's our original conditional statement. It says, if the polygon is a pentagon, then it has 5 sides. This is a true statement because pentagons have 5 sides. So I'm going to put a T here. Okay, so we want to look at the converse statement and decide if that is true, and we can make a biconditional statement out of that. Okay, so after the if is our hypothesis. If the polygon is a pentagon, and after the word then is our conclusion, is it has 5 sides. Okay, so let's flip those two and write our converse. So if it has 5 sides, comma, then the polygon is a pentagon. Okay? And that is also true. If a polygon has 5 sides, then it's a pentagon. And if some polygon has 5 sides, no. And that is also true because if something has 5 sides, then that polygon must be a pentagon. So since our original conditional statement and our converse is both true, we can write a biconditional statement. So the polygon is a pentagon if and only if it has 5 sides. Let's do another example. This conditional statement says, if you run, then you are fast, okay? So after the if is your hypothesis, and after the then is your conclusion. But this is a false statement because someone can run and not be fast. So because this is false, we cannot write a biconditional statement, but we can still write our conclusion, which is where we flip them, okay? So we would write, if our conclusion, you are fast, comma, then your hypothesis, you run, which is also a false statement. Let's do another example, okay? So this original conditional statement says, if you like math, then you like science, okay? If you like math, then you like science. After the if is your hypothesis, and after the then is your conclusion, okay? This is a false statement, okay? Because you can like math and not like science. When I was in high school, I definitely did not like science, but I always have liked math. So for me, this is personally false. It's solely based on opinion, okay? So because this statement is false, we cannot write a biconditional statement for it, but we can still write the converse, which is where we flip the hypothesis and the conclusion. So that would turn into, if you like science, then you like math. Which is again a matter of opinion, which is also false. There's no proof that if you like science, you also must like math. Okay, last one. This problem gave us both the original conditional statement up top and the converse statement already for us. Okay, and we have to determine if these are both true. If they're both true, then we can write the biconditional statement. Okay? So the first one, our original conditional statement says, if you can run for president, then you are at least 35 years old. That is true. You cannot run for president if you are under 35 years old. Okay? If you are at least 35 years old, then you can run for president. And that is also true. You must be at least 35 to run for president. Since both of these statements are true, we can write our if and only if statement or a biconditional statement saying you can run for president if and only if you are at least 35 years old. Okay? So you can run for president if and only if you are at least 35 years old.